Still, many of them didn't join. The old students also didn't join, many of them. Arpita is not there. Many of them didn't join. So for graphical method, for first thing you need to know these things. You need to know displacement time graph. Displacement time graph is like I'll take it three cases for displacement time graph. So one case for uniform motion, one case for object at rest. So another will be the non-uniform motion. So for this, I will plot the graph and I will discuss now. For a uniform motion, displacement I will represent it as S and time as T. Displacement time graph for a uniform motion first. Who can tell that how it will be their uniform motion? Who can tell me the uniform motion graph, how it looks like?
Straight line.
Straight line, how it's straight line? There is a name for that graph.
Parallel to the time x-axis.
Parallel to the time axis. No way.
Graph.
That is not the uniform motion. Uniform motion. Uniform motion means
So linear.
Yes,
sir,
linear. The object covers equal distance in equal interval of time. So that is a linear graph. So this is the linear graph which you learned in the mathematics also, right? The graph looks like this for a uniform motion. And if you take the slope of this, so what you will get the slope of this graph? Slope of this graph will give you what?
Tan theta.
Displacement resistance. Okay, tan theta. What is the tan theta called? Can you tell me?
Acceleration.
Acceleration. Yeah, that is the reason I am taking these topics. Acceleration will give distance time graph. What is tan theta here? Okay, what is tan theta? This is theta. What is tan theta? This is what? This perpendicular line is what? And this is what? What is this perpendicular line?
Displacement.
Displacement. Okay, tan theta is equal to opposite by adjacent, right? This is the right angle triangle. Opposite is displacement. And adjacent is time. What is displacement by time? This adjacent is time here. Opposite is displacement. Adjacent is time. Displacement by time is what?
Velocity.
Velocity. So that means the slope of this graph is velocity. All right. Did you get it? The slope of displacement versus time graph is not the acceleration, it's the velocity. And now we can go for other things. See, those who are coming late, I'm repeatedly telling you how to come on time. Again, see, I have to go back to the one more window I have to admit. For 36, 40 members, if I go on doing the same thing, when I will teach them? You have to properly, you should be obedient for the things, na? So if the object, second case, I will make it if the object is at rest. What kind of graph you'll get if the object is at rest? What is the graph? If the object is rest, displacement time graph is what? How it looks?
Parallel.
Yeah, parallel to time axis.
It is
So
parallel to time.
yeah, it is parallel to time axis. So simple it is. And what happens to the velocity here? What happens to the slope of this graph?
0.
0. Slope will be 0. Velocity will also be 0. because the object is at rest. There is no movement. If there is no movement, then the velocity is 0.
Constant.
Yeah, constant is displacement is constant. The velocity is 0. The velocity is 0. There is no constant here. Here it is constant. Here it is constant in the entire journey. But here it is not constant, it is 0. There is a difference, difference between these two graphs. Then you can call uniform motion. Uniform motion can be like this. An object is traveling, it's changing unequal displacement, it's changing unequal displacement in equal interval of time. So that is called non-uniform motion. For non-uniform, it can be anything. It's not only one graph, it can be anything. So other than a straight line, this is uniform, this is for a rest, this is for a non-uniform. So where here the slope is, if you have to draw a tangent for it, that I will come back later, how to do for all those things. Now again, we will go for velocity time graph. For a velocity time graph, if I draw for a first case, that is uniform motion. Velocity time for uniform motion, if I draw, how it looks like. Can anyone guess? For a uniform motion, if I draw a velocity time graph, how it looks like. Same thing. What happened in the uniform motion? What happens to the velocity? What happens to the velocity in uniform motion?
So velocity is constant.
Constant means how the graph looks like for a constant.
Sir, parallel to t.
Yes, parallel to t. So simple way, parallel to t. That is, this is for uniform motion. Uniform velocity time graph for uniform motion is just like parallel to the time axis. Now let us take for another case. We will get uniformly accelerated motion. For a uniformly accelerated motion, the graph looks like this. This is the velocity and this is the time. For uniformly accelerated, the graph will be like this. Meaning is the acceleration is constant. The rate of change of velocity is constant. Always the velocity changes in an equal time. So for example, I will take like this. There is a train. So it is traveling in a straight line. So we have a train, it is traveling in a straight line. So it in the first when t is equal to 0, the velocity is also 0. But after 1 minute, if you observe this, after a minute, the same train, after time 1 minute, it gets velocity. Now let us say that it gets a velocity of 10 train. I'll talk about let me say 1 kilometer per minute. Okay, so this is it is going a little slow. Then after one more minute, if you see that the same train gets the velocity 2 kilometer per minute, and after 3 minutes, the same train, if you see, then it gets 3 kilometer per minute. Means the velocities start increasing from here to here. The velocity increased is 1 kilometer per minute. From here to here again 1 kilometer per minute. So the velocity is increasing with respect to time. So this is the meaning of uniformly accelerated. Now if you talk about the acceleration, after each minute the object is accelerating with 1 meter per second. 1 minute per 1 kilometer per minute square. It's accelerating in that way. So that means for each minute, the velocity, increased velocity is 1 kilometer per minute. Okay, so that is the way it goes. So then if you plot the graph between velocity and time, you'll get the linear graph. So now if you take the slope of it, what you'll get? Quickly you have to tell me what is the slope of this. I'm not going to repeat all these things every day. So I am repeating twice this same topic. What is the slope of this graph? Slope is nothing but Tan theta, what is that? Here, tan theta will be give what? What is in the y-axis? What is this? This is a parallel line to the y-axis. What is this represents then? What this represents? What is this? What is this represents? This y-axis, what it represents? Look at this triangle. What this side, opposite side represents? Is the represent the displacement or velocity? The tan theta is equal to what is this opposite side? This is what? This is parallel to the y-axis. What is written in the y-axis? What we represent in the y-axis?
Velocity.
Velocity.
Velocity. The same it represents the velocity, right? How it represented here, it is the displacement it represented. In the displacement time graph, this represents the displacement. Here in the velocity time graph, this represents the velocity. So tan theta is nothing but velocity, and adjacent is nothing but the time in this triangle. Adjacent is time. So velocity by time is what?
So acceleration.
Acceleration. So that means the slope of velocity time graph gives you the acceleration. Understand that. That is the important thing you need to know as slope of velocity time graph gives the acceleration. This you learned in the 9th standard also. Now we represent the another one important thing you need to know. What is this represents? This area represents what? Velocity time graph. The area under the velocity time graph represents what? That you need to know. I'm shading that area. Displacement. The velocity. I'm not talking about speed versus time graph. This is velocity versus time graph represents displacement. Here also, this area gives you the displacement. This is the displacement. This is displacement. Understand these things. What I'm writing here, velocity time graph slope gives acceleration. And velocity time graph, area under velocity time graph. Velocity time graph gives displacement. Okay, these are the very important things to understand first. Once you understand this, then we can go for the equations of motion to derive those equations of motion. This is the very basic things in the physics. So I'm repeatedly telling you already for the old student, I told you to write the 9th standard syllabus. Once again, that is the syllabus we are continuing. 9th and 11th are related. 10th and 12th are related. That is the way we get it. 9th, whatever the 5 chapters are there, all the 5 chapters is there in your first part of the 11th standard. Now I am discussing the equation, the motion in the 1 dimension. The same chapter is there in the like in the 9th standard. You learned a chapter called motion. That is nothing but a motion in a straight line only. There also you studied. There also they discussed all this displacement time graph, velocity time graph, uniform, non-uniform. We have also discussed the equations of motion, and the same thing we are carrying out here. So equations of motion, and there is another chapter called in your 9th standard, the laws of motion. That laws of motion I'm going to take next chapter. The 5th chapter in your syllabus is laws of motion, and you have studied one more chapter called gravitation. That is also there here. But that there is a basic, that one here we are little upgrading our knowledge. The only thing that we are going to use a different mathematics. The different mathematics is nothing but the language. The language here we are going to use a vector and the calculus. So that I am going to take slowly the what is the calculus, what is the vectors. Once you understand that concept is same, the same concept, we are using a different language and we are representing it. You understand that one. What I am going to tell about the mathematics is very, very important. Very crucial for studying the physics in the entire 2 years of your journey from 11th and 12th. So if you're not understanding the vectors and the calculus, what I'm going to teach the next week, then you cannot understand the physics of entire 11th and 12th. If you're not understanding the vectors and calculus properly, cannot understand the physics of 11th and 12th. You have to be very careful, and you have to read some mathematics uh, materials which I give in the Google Classroom by yourself for the extra knowledge. Then only you can proceed properly and your score will be good. Otherwise, you will mug up the topics. You will mug up the topic means you will mug up the equations. That is useless. If you mug up the physics, it is useless. You have to understand and learn it. That is important. Mugging up, biting the things. Mugging up means biting. U is equal to S is equal to UT plus half, S is equal to UT plus half, you will be doing that. That is not how it comes, you understand. Then it remains in your mind forever. You won't forget. So for that, you need to understand the mathematics. Very important. Very important. Okay, and for that, every day you have to attend the classes. Today you will come, then tomorrow absent. Then that won't work, because every topic is related. Everything is related in the physics. Today what I will teach, tomorrow it will be there. It will be there. I thought yesterday these things. Last class, if you remember, that the graphical things I told, but very few were there. And now you are not giving answer. Be concentrated. Don't deviate your concentration. It's very important. If you aim so many things and you come to 11th standard, and if you deviate from your studies, then God also will not help you. Okay, so equations of motion. Equations of motion is the mainly thing that it relates the final velocity, initial velocity, displacement, acceleration, and time. These quantities, it will relate. We make some relations among these quantities. So that is the beauty of these equations. If you derive that, I will derive and show you how it relates. If you know the three quantities, you can always find the other quantity, the numericals. So this developed by the Newton helped us to understand many of the things, many of the realistic. We started applying these things, and we used to get to know the different quantities. Okay, and this equations only obeys in a certain condition. So that the certain conditions I'm going to give it. So that I will make it as an assumption. What I'm going to assume, the first assumption is this motion. This motion is straight line. This whatever I'm assuming, it's a straight line. Then only that equations is true. I'm going to derive the same equations for it when it is a two-dimension. That is in the next chapter. I'm going to derive that. The same equation I will apply for the two-dimension. Then you can get to know that. And another assumption is it is uniformly accelerated. If the motion is uniformly accelerated. Motion meaning is if the object should have a constant acceleration. That is the meaning of it. The object should have a constant acceleration. And the third one is to derive this time, you can take that initial velocity 0 and you can derive. So, but I am taking initial velocity not equal to 0. So initial velocity is not equal to 0. U means initial velocity. Understand that. Then if these conditions, if these assumptions, if I have taken care, then you can plot the graph. The graph looks like this. If you take these conditions consideration, if you plot it, because uniformly accelerated motion is linear graph, but velocity, initial velocity is not 0, means the graph will not starts from the origin. It starts from somewhere here. So that is nothing but our initial velocity. This is nothing but our initial velocity. This is u. The object starts from a point A. Suppose, let us take this one. I will take, this is the, suppose the bus is traveling here. So always my buses will be in a rectangular shape. So there is a two wheels, and this is my bus, or you can take consideration any of the vehicle. So you can take it as a bus, or you can take it as an Mercedes car, you can take it as an Audi car, whatever it is. So that is my vehicle here. So we're just traveling with a constant acceleration. The acceleration is constant. Okay, yeah, the acceleration is constant. The car is traveling here. So meaning is it's traveling in a straight line, the acceleration is constant. But when it started journey, when the t is equal to 0, it was already having some initial velocity. Initial velocity was not 0. It started from point A. At the point A, it was having constant acceleration. At time is 0, and the velocity was not equal to 0 at the time. And it traveled some distance b. Here, it traveled some distance up to P point when time was some value. It was having some value t. The time was equal to t dash. So sometime after 30 minutes, we are observing the same vehicle. So when we observe the same vehicle after 30 minutes, the velocity became v. That means this is nothing but the final velocity we consider. At the point B, the velocity was v. At the point A, the velocity was u, which is not equal to 0. And after when it reaches to point B, also the acceleration was constant. This is the visualization of the things. Then if you plot the graph for this motion, then you'll get this kind of graph. Because when the time was 0, the initial velocity is u. Suppose 10 meter per second or 20 meter per second. It was having some velocity. And this is the point A which I am calling there. This is the point A which I am calling. And when it reaches the point B, the velocity of that vehicle is v. For getting that in the graph, we will draw a perpendicular line for the y-axis. So we will get that v. So that is the v. And now I will draw a perpendicular line for the x-axis also. And I will get the coordinates of this. When I draw the perpendicular line for the x-axis, this is the time. And here I will get the t. This is the t. This point represents the t on the x-axis. The coordinates of this point is t comma v. Coordinates of this point is 0 comma u. Why it is 0? Because t is equal to 0 at this time. So this you need to understand. And again I will draw one more parallel line for the x-axis. This is nothing but a theta. Alright. Now tell me, I will name all this sides. This is already named A, this is B, and I will name this as C, and I will name this as D. And this is already named as O. This I will name it as T. Now tell me what is tan theta. In the above equation, tell me what is tan theta. Above graph, what is tan theta? Tan theta is slope. We already know that. What is that slope? Can you tell me what is the slope? Think. Slope is nothing but your opposite in this triangle. In the triangle ABC, in the triangle ABC, you observe. In the triangle ABC, tan theta is equal to slope. Tan theta is equal to is what?
BC by AC.
BC by AC. What is BC in the triangle? What is BC in terms of velocities? What is BC?
V minus
Final velocity minus initial
V minus
V
velocity.
minus u. So because
E minus U.
yeah, this is BD is nothing but V. This BD is nothing but V, and this is nothing but U. DC is U. So look at this. BD, those who didn't get it, look at this. BD is nothing but final velocity, and DC is nothing but initial velocity. Then BC is nothing but BD minus DC. BD minus DC, that is nothing but V minus. So BC is V minus. So V minus U divided by AC is nothing but T minus 0. T minus 0 is T. So this AC will give you the time. So total time. So what is this V minus U by T? What?
Acceleration.
Acceleration. So this is our first equation actually. This is the first equation of motion. This is nothing but a consequence of the definition of acceleration. Definition of the acceleration itself talks about change in velocity divided by time. So this is giving us change in velocity divided by time. So that means we can write this equation in modification way, that is u plus 8. V is equal to u plus 8. This equation, in this equation, A is constant. A won't change its value, but initial velocity and final velocity values can change. And time also can change. That means this equation gives you the relation between time and velocity. If you know time and velocity, then you can find the acceleration. If you know the acceleration and time, you can find out the velocity. This is the first equation of motion. So I derived the first equation of motion. For the second equation of motion, I do one thing. I will, for the second, say, I already this equation gave the relation between time and velocity. Now I want to know the relation between, let us say, time and displacement. I want to know the relation between time and displacement. I don't want velocity thing in that equation. So that is second equation. For that, what I do is, I will find out, I want to find out, displacement, how much distance it moves. This distance I need to find out. This is the distance, yes, I need to find out the yes. For that, I already discussed in the previous thing that the area under the velocity time graph gives me the displacement. The area under velocity time graph gives me the displacement. That means I'm going to find out this area here. If I calculate this area, that area gives me the displacement. I know it, right? Now let us calculate how it looks like. This is looking like trapezium, but I won't consider it as a trapezium. Now I'll divide this into two shapes. One is rectangle, and one is triangle. One is rectangle, and one is right angle triangle. I divide that way. And I will calculate the area. Right. Now let us say area of O, let us say ODCBA. ODCBAO. So that area I will divide into area of rectangle. I'm writing the shape of rectangle. That is, what is the rectangle? OACD. OACD is the rectangle, plus area of triangle ABC. Right? So look at this. This shape I divided into two parts. So one is this rectangle. Rectangle is OACD. This is a rectangle, and the triangle is ABCD. Right? So what is the area of rectangle? You have length into breadth. Length
half into base into height.
Yeah, area of triangle is half into base into height. Area of rectangle is you can write AC. AC into DC I can do. AC is the length, DC is the breadth. So I can write it as AC into DC plus half into base. Base of the triangle is what? Base of the triangle is AC and height of the triangle is DC. So base is again AC and height is DC. Now you know what is AC. AC is nothing but T. What is DC? DC is nothing but U. Right? So let us substitute those things. Plus half into AC again T into DC is nothing but we already know BC is nothing but V minus U. Substitute that. All right. Now we get that as UT. This will become UT plus of now what is V minus U? In the above equation, what is V minus U? Here, what is V minus U in this equation? AT. So substitute that here. V minus, because I don't want this in this equation, I don't want the final velocity. I don't want to express the displacement in terms of final velocity. I want to get the relation between distance, time. I want to get the relation where acceleration is constant. V minus U is nothing but AT. So I substitute that from the equation. So we know that V minus U is equal to AT from the equation 1. So since I represent that, if I write like this 3 points, that is the meaning is since. So I substitute, now it gets ut plus of 80 square. And area under that tire is nothing but the S, that is displacement. So S is equal to ut plus half 80 square, I got it. S is equal to ut plus half 80 square. This gives relation between S and T, where U is constant, U is initial velocity, we already taken constant, A is constant. So if you know U, A and T, you can calculate the displacement. Now, third equation, you can do 3 ways. So one way is calculate the area under that graph completely considering as a trapezium, and you can calculate, or else you can calculate by using this simple first equation you consider, that is V minus U is equal to 80, and you can square both the side and you can do it. So I will should I do in that manner or? Okay. I'll go for this is half t square ut plus half t square. Okay, I'll go for the trapezium method only. So what is the area of trapezium? Area of trapezium formula.
Half into sum of parallel side.
Parallel sides into adjacent sides.
Half into
Sum of the parallel sides
sum of
into
parallel
adjacent
sides,
height. Into adjacent height.
sides into height.
Add
Okay, adjacent height. Yeah, adjacent height. Now you need to area of trapezium will give the again displacement, because the area under this graph will give the displacement of what is the sum of parallel lines in this trapezium. What are the parallel lines? This you need to visualize the trapezium. You should reverse it. You should reverse and you have to see that. What is that? Which are the sum of parallel lines here?
OA plus BD.
OA plus BD.
OA plus, yes, OA plus BD, or you say that DC plus BD also you can say, right? OA, because OA is equal to DC, DC plus BD I can say. Then what is the height of this trapezium? What is the height of this trapezium?
AC.
AC is the height of this trapezium. Right. What is BD? So what is DC? What is DC? DC is what? Here, look at this DC. DC is what? DC is initial velocity, right? R OA or DC is equal to initial velocity. This is also equal to OA. So that is equal to U, and BD is V. Substitute here. U plus V, right, into T. Right, I got this one. Now what you need to do is, you need to remove this T. I don't want T in this expression. For that, what I do, again, I'm going to use the first equation. From the first equation, we know that V minus U is equal to AT, or else I can write T is equal to V minus U by A. I can write it from the first equation, because I need to remove this T from this equation. For that, I need to bring back that from the first equation. I need to bring back what is T. So substitute T in terms of V minus U by A. I can write like this. Am I right or wrong? The first equation, V minus U is equal to AT. So I am bringing T is equal to V minus U by A. Then I can write now 2 and A, I can take this side. So it becomes 2AS. Then this equation becomes now U plus V into V minus U. It comes like this. What is this A plus B and A minus B? I can write this as B plus
A square minus
A square minus B square.
Minus
B square.
A plus B into A minus B. is equal to a square minus b square. Right, substitute, I'll get b square minus b square. So 2as is equal to v square minus v square. That is the way you can do it. Okay, so this is another equation where there is no time term in this. There is no time term. It only gives relation between the s and velocity. That is v, final velocity, where u and a are constant, where initial velocity and acceleration is constant. So it gives relation between s and v. S and v are the variables. So relation these two variables it gives. The second equation gives the relation between s and t, where u and e are constant. The first equation gives a relation between time and velocity, where acceleration and initial velocity is constant. So this is the important derivations of your 11th standard of third chapter. Simple derivations. This is, I'm starting from simple derivation. You are having plenty of derivations in the 11th standard. Approximately, if you take it, more than 30 to 40 derivations you will find in your 11th standard textbook. This is the simple one. So that's why I'm telling you, you need to be very careful in the mathematics. So otherwise, heading towards your journey will be very difficult. Mathematics, basic mathematics. I'm not talking about, see, now I'm asking what is the area of trapezium. You should be very quick and to give that answers. You should be very quick. If you know, I don't know, then I cannot solve this one. I cannot tell you how you got the area of trapezium. I just use from the mathematics. So this is very important. And I asked like, yeah, what is a square minus b square? So you should be very quick to remember all those things. I get many of the things, like I may ask you a cube minus b cube. I may ask you different formulas. What is the area of the cylinder? What is surface area of cylinder? What is the volume of the cylinder? What is the surface area of the cone? Volume of the cone? You have to remember all these things. We require for the physics. Those are developed to understand the concept of the science. Okay, mathematics is a language of, most probably we can keep it as a language of physics. So learn all these things, go back and make your basics strong. Mathematics, recall all the formulas of the mathematics. Triangles properties which you studied in your 7th and 9th and 10th. You have studied so many triangle properties, right? Exterior angle property, some of angle property. So bisector property, or you have learned BPT in the 10th standard. All these things we will use in the physics. So be careful. You should be strong in the mathematics. Don't forget the things which you learned in the mathematics. Okay. So by this, I will put up this in the Google Classroom. You can refer, and we will take up some problems on this. Don't leave now. I'm going to take the attendance. So some of the things